ladies and gentlemen. Welcome to our recommend talk hosted by Princess Jurapon Science High School Pathum Thani and the Chinese University of Hong Kong, Shenzhen. So my name is Amanya Rung Sang. I am your host for today. And today I'm delighted to invite everyone to Princess Jurapon Science High School Pathum Thani auditorium. And we have the audience from another campuses that join us via live stream on YouTube and Zoom. So to begin this event, let me briefly go over the agenda for today. So the first one, I will introduce our esteemed speaker. And today he has prepared a special lecture for you guys. After that, we are going to proceed to the main talk about the opportunity at the Chinese University of Hong Kong, Shenzhen. And then there will be Q&A question for you guys. So if you have any question about the lecture or the scholarship, please feel free to note down your question. And for the audience who join us via YouTube and Zoom, you can submit the question or the inquiries in Google Form. So to begin this event, I am very honored to introduce our special guest, Professor Dr. Shaw Bowen. Yes, the Executive Assistant Dean. Yeah. Yeah, President Fellow of the School of Science and Engineering from the Chinese University of Hong Kong, Shenzhen. So you know that today he has prepared very special topic about physics proton, about the 100 year of the proton physics, and he will provide our main talk and insightful about the scholarship that available in the university. So everyone, please welcome Professor Dr. Xiao Baoren on the stage, please.
Hello. It's a great pleasure and a great honor to be here. I really enjoyed my first trip to Thailand, and I think this definitely will not be the last. And I really enjoyed my trip here. I came last night, and everything was great. And today, I finally was able to I'm able to come and see the school myself. I remember we invited some students to Shenzhen this summer, and they enjoyed our campus very much. I hope you can also come to visit our campus next summer, probably in July. And we will be very happy to host you in the summer for a week, and you will enjoy the summer camp a lot. So this is just the advertisement for the summer camp. Now, first, let me give you some introduction to the research or the physics that I really interested in. This won't be like a lecture, but I try to make it as pedagogical as possible. So let's talk about 100 years of proton physics. So what is proton? I guess you know what is. Before I talk about proton, I really wanted to talk about the J.J. Thomson. Have you learned J.J. Thomson? Yes. So he got Nobel Prize for discovering electrons. So what he did essentially is to put a voltage between two metal plates. And then he discovered there is a ray of particles going from one plate, metal plate, to another metal plate. And then he put a magnetic field onto this this ray of particles, and he was able to show that these particles are carrying negative charge. Negative charge. That is why he discovered the electrons, and he got Nobel Prize for it in 1906. And then after discovering these electrons, he made a big mistake. But it's not. Do you know what mistake he made? No? Yes? Yes. So he made a big mistake. But it's not, it's understandable mistake. It's a very understandable mistake. I will talk about why it's a very understandable mistake, but it is a mistake. Let me go through the logic that he had in mind. So he discovered electrons, but matter are made of charge neutral stuff. This thing has no charge. So it's charge neutral. It means that there are equal amount of positive charge and a negative charge. So he discovered negative charge electrons. Then there must be some positive charge things in the matter. So he came up with this model, Plum-Pudding model, for matter. So any matter or any atom is made of this pudding in the middle, like a cake, and then there are many electrons, many electrons, like grape, like raisin, randomly distributed in the cake. So that's what's so-called plum pudding model. And this is the biggest mistake in physics, and people often talked about it. And he says that how wrong he was. Indeed, this is a wrong model, but it is understandable. Why? Because in 1906, there was no quantum mechanics. Before quantum mechanics, you cannot have electrons moving in the atom, because he knows so well that if you have electrons moving in the atom, it will radiate energy. It will lose energy. It cannot be stable, because you cannot lose energy all the time, and then you won't have a stable atom anymore. So that is understandable, because before quantum mechanics, we cannot have a model that is stable for atom and electrons to exist together without motion. So then later on, Rutherford was a student of J.J. Thomson. He believed what J.J. Thomson said, but he wants to test it himself. What he was really good at it is that he was able to have this kind of alpha particle. He was able to prepare alpha particle. That's his special technique. So he was able to prepare a lot of alpha particles, and these alpha particles was shoot into the gold foil. And then surprisingly, some of the alpha particle occasionally bounce back 100%. So if you have this pudding model, you can never have this 100%, 180-degree bounce back case. So what he realized eventually is that the mass of atoms are really concentrated in the middle, and electrons are just flying or rotating about the nucleus in the middle. That's the model, so-called Rutherford model. This Rutherford model later on becomes the popular model in the end. That also earned his Nobel Prize in physics. So, and later on, it's really because physics is really a science, experimental science. We have to, no matter how reasonable the Plum-Pudding model was, but we have to test it in experiment. So it was the experiment, Rutherford experiment, confirmed that the Rutherford model of the nucleus of the atom. And then this becomes the birth, this also give the birth of quantum mechanics. Then people ask, okay, now we have this model of electrons surrounding nuclei, and then how could they become stable? It is only in the quantum mechanics that we can eventually explain why the electrons can stably exist in the atom. That's so electron has to be wave in order to be standing wave, to be precise, to exist stably in the atom. So later on, it was also Rutherford who discovered the proton. What he was able to do. So first, why proton is called proton? Do you know? Because it came from Greek. In Greek, there is a word called protos. Protos means first in Greek. And because proton is the first, is the nucleus of the first element in the periodic table. So you have the periodic table, you all learn chemistry, and then the first element is hydrogen. The nucleus of hydrogen is proton. So that's why we call it. So he invented this word proton from Greek. So that's why proton is called proton. And he discovered by shooting, you see, alpha particle again. His specialty is alpha particle. He used alpha particle to shoot on everything. And that's why in 1919, 105 years ago, he discovered the proton. And right now, we really know proton fairly well. We know proton has a mass. Proton has a spin, and also proton has magnetic moment. So proton is a charged particle with positive charge 1. And then because proton has something like the Earth, it spins. If you imagine that you have a rotating charged particle, this will create magnetic moments, magnetic fields, and magnetic moments. And that's something that we also can measure and can study. That's the property of the proton. And proton is the most important building block of our visible matter. Everything here has a lot of proton in it. Has a lot of proton. Okay, so and one of the most important thing is that proton is stable. Imagine that if proton is not stable, we will not have a stable nature or universe anymore. So proton itself is very stable. It doesn't decay. It doesn't go anywhere. It doesn't suddenly disappear. So that's something that made our universe stable. That's very, very important. One of the interesting things happened a few years later after the discovery of proton is that this Arthur Stern, he also got Nobel Prize in 1943 for this discovery of the magnetic moment of proton. He measured the magnetic moment of the proton because proton has mass, proton has charge, and the proton is rotating, and then it must have magnetic moments, magnetic field, and then his magnetic field is much bigger than people expected. It's much bigger than people expected. People were stopped. People thought proton is a point-like particle. Has no size, has no structure, has nothing. It's just a particle with no structure, a point. People thought. And then if you really believe that proton has no structure, and then people computed the magnetic moment of that proton, and then they got 1 in front of it. But what happened that later on, Arthur Stern discovered is not 1. The value of that proton magnetic moment is not 1, it's 2.5. So that was indication, that was the most important indication that proton is not a point-like particle. Proton has structure, really has structure. And then here comes Robert Hofstadter. I'm not sure, do you watch sitcom or not? Do you know the sitcom, The Big Bang Theory? Oh yeah, so okay, so a few of you watched The Big Bang Theory. So it's a Big Bang Theory is a sitcom for physicists students. It talks about everything about physics, but it was fun. It was fun to watch. I really enjoyed this series. And one of the actor, his last name in the show is Hofstadter. Do you know his name? Nennert. His full name is Nennert Hofstadter. And the name was chosen after this Nobel physicist, Nobel laureate. So his contribution to physics is really discovery of proton size. He was able to shoot high energy electrons onto protons, and he was trying to scatter the proton and measure the scattering angle, also the reaction rate. And then he discovered that at 1 Fermi, at 10 to the minus 15 meter scale, the scale of 10 to the minus 15 meter, the proton stops to behave like a particle, like a point. It means that it starts to look different, like a point, more like a structure, or a particle with internal structure. So that's why people start to realize that proton has a size. Its size is about 10 to the minus 15 meters. Okay, and that's his contribution. Finally, and then next in more than 55 years ago, so we have these three gentlemen. They carried out this experiment further. So they shoot even higher energy photons, and higher energy electrons onto the proton. And then what they can do, they can really break the proton into many pieces, And then they can really study the inner part, the inner structure of the proton, inner content of those of proton, because the proton now is broken up. And then this, most interestingly, the first discovery they found is that proton consists of point-like particles. And then they were puzzled by this. So they break the proton and then realize the protons are made of point-like particles. And then later on, we call those point-like particles quark. So we call them quark in physics. And now we know there are 3 quarks in the proton, 2 U quark and 1 D quark. And U quark carries 2/3 of positive charge. D quark carries minus 1/3 of the charge. And this plot is a pretty technical plot, but essentially it's flat. It means the quarks are point-like. The quarks have no structure. And I can even tell you, up to now, even 55 years later, we still cannot find any structure of the proton. Any structure of the quark. The quark are still right now behaving like a point-like particle. And even after 55 years of experimental study, higher energy, smaller and smaller structure, we still find that quarks are still point-like particles. And this is a bit summary of what we realize. So now we know atom has 10 to the minus 10 meter size in size. And then we realize the nucleus is much smaller. And then we have proton, and then we have quark. Quark has acting like a point-like particle. So we say their size are less than 10 to the minus 18 meter, or less than 10 to the minus 16 centimeter. So electrons and quarks are behaving like point-like particles, are really point-like at the moment. And then you want to ask yourself a very interesting question. So I have point-like particle U quark and D quark inside the proton. And I told you before, proton is very, very stable. Proton is very, very stable. And how could this happen? You have to think about it, because U quark and you have two U quark inside the proton, and the U quarks, they are repelling each other because they carry the same charge. They do not want it to be forced to stay in the same proton. So there must be a very, very strong force to bond them together. What the force is called color force. Then there is a color force, quote unquote, color force to bind those electric charge together to make the proton stable. People realize that you have to have some stronger force to bind these charges together. And right now we have discovered many, many different quarks, and we have discovered many, many quarks. And we have U quark, D quark, charm quark, strange quark, top quark, and also bottom quark. And the underlying theory that describes everything is called quantum chromodynamics. The chromodynamics is they realize that you need the gluon. You need something called a gluon to propagate the force, to carry the force between quarks. So let me ask you a question. So let's think, what is the nature of force? You have all learned physics. So let me ask you a question. What is the nature of force? What is the nature of the force? What is the nature of the force? Nature, yes. What is the most fundamental property of a force? No? Yes?
Maybe it's a vector and a size of it.
A vector and size. Yes, that's the nature, but that's not the most important nature of the force.
Is the force the ability to change things?
Say it again.
The ability to change things, like the force
Ability to change the motion. Oh,
yes.
Right. But that's still not what I'm looking for. Still, what's the nature of force? The nature of the force is interaction. Interaction. And the funny thing is, the force that we normally thought about is this: I press the table, I apply force to the table, I hold up the mic, and then because I have to use my force, my hand, to provide a force to lift, to counteract the gravity. But have you thought about the nature of the force? And the nature of the force is actually interaction. Interaction. What is interaction? What is the difference between interaction and a force? The interaction must have something to carry the force. You must have something to carry. And the force does not have to be in touch. The existence of force does not have to be, you do not have to touch something to apply the force. For example, we are so far away from the sun, but we are feeling the gravitational force of the sun, right? We have nowhere in touch. We are absolutely not in touch with the sun, but we are feeling the gravitational pull of the sun. Then we have to think about it. How could this happen? Force must be carried by a particle. So in modern physics language, force must be carried by a particle. For example, if you have two charges, one positive charge, one negative charge, they are pulling each other towards each other. And then what is the force carrying particle? It's the photon. It is the photon that carries the force between two charges. Similarly, if you have two like U quark, you must have something to carry the force. The force carrying particle is called gluon. And that's another way to understand there must be something to carry the force, and there must be some additional particle. And then we realize we also call them gluon here. And the easy way to really to understand this is that if I would like to apply a force to you and without touching you, what should I do? I could do this. I could throw you a bottle of water. When you catch the bottle of water, you convert this momentum of the bottle of water, and you have to, in order to stop the bottle of water, you have to use force. And then that's the nature of the force as interaction. Okay, so there must be something, and then I would like to give you a brief introduction of QCD. This is called quantum chromodynamics. The QCD, quantum chromodynamics, is actually the theory describing the inner structure of the proton and the inner dynamics of the proton, and then also the action or dynamics or the interaction between quarks and the gluon and other things. And the funny thing is, I met Hooft a few years ago when I was a student, not a few, 20 years ago when I was a student in Boston. So he was giving a lecture on quantum chromodynamics. He was very disappointed. The reason he was disappointed because he was the one who first discovered a very important property of the QCD called asymptotic freedom, but he wrote it only on the blackboard. He didn't publish that result, so he missed out his second Nobel Prize. He got Nobel Prize in 1999, but he said he should. I think probably he should get his second Nobel Prize. There are many very interesting dynamics and very interesting results to study, and I won't go into the detail since I already so QCD. The funny thing about QCD, or the funny thing about gluon and also this proton inner structure is that QCD or the gluon force, color force, is very confined inside the proton. If it go outside the proton, there's no strong force at all. But if you go inside, and then you suddenly feel the proton, you feel the strong force inside the proton, and it's like if you try to pull two quarks away from each other, and then later the force becomes really strong. But if you are not pulling the force between two quarks are like a rubber band. If it's very close to each other, they don't have any force. But if you try to pull them away, suddenly the force increases quite dramatically. So that's why we'll never really see the strong force or color force outside the proton, because they are only confined inside the proton. If you try, it only becomes important if you try to break the proton. So that's something we call confinement, because color or the color force strong force are confined. They only exist at the 10 to the minus 15 meter scale. And the asymptotic freedom is that if two particles are very close to each other, they don't feel the force. The force is almost zero. That's why they almost look like something free. Or the particle inside the proton look like something free. Okay, and I also wanted to talk about a little bit something called QCD jet. The jets, the jets are something that helped us to discover the inner structure of the proton, and also helped us to discover the existence of gluon. What really happened is that usually you discover quark by colliding by colliding like two particles together and then create a lot of new particles. And most of the time, for example, if you collide the two electrons, one electron, one positron, and then one is carrying negative charge, the other one is carrying positive charge, and then they annihilate, but there are a lot of energy in the middle. So the energy has to go somewhere. And sometimes, most often, they become a pair of quark. They become a pair of quark. And then how do you know that's a pair of quark? Because in the detector, sometimes you see you see something like a bunch of particles going on. A bunch of particles are going on. And then they are located, these particles, many particles, they are concentrated in a very, very small cone. They fly almost in the same direction. So eventually you measure the energy of those quark particles. And these are called dijet events. You have one jet going this direction, carrying a lot of energy, the other one going the opposite direction, carrying a lot of energy. But sometimes we have three jet events. That means one of you have one of the jet coming out in this direction, and that's actually the gluon. So that's jets using this jet language, and also the measurement of jet, we actually can discover the gluon as well. So right now, that's how we discover the gluon. Looking to the future, what we wanted to do is really to understand the inner structure of the proton. So proton has spin, proton has mass, and also one of the most interesting questions is, where does the mass of the proton come from? If you think about it, it's a very interesting question. Because proton, now we know, is made of quark and a gluon inside. But I have to tell you that quark is almost massless. The gluon is also massless. So where does the mass of the proton come from? Sorry? Higgs boson. Oh, you learned a lot. That's okay. I'm very impressed that our science students know Higgs boson. Very, very good. Very good. Unfortunately, Higgs boson cannot explain the proton mass. It can only explain the quark mass. So it can only tell us why quark and the electron have mass. But the Higgs mechanism cannot tell us why proton has mass. Because right now, imagine that a quark mass is only like 1% of the total proton mass. So 99% of the proton mass are uncounted. And later, so naively, you can get the help from Einstein. I'm not sure you have, maybe you haven't read the old paper from Einstein, but the most influential paper from Einstein. But you all have heard the formula. E equals mc squared, right? E equals m, but that's not what Einstein wrote originally. Einstein wrote m equals E divided by C squared. He never wrote E equals mc squared. But you say, well, this is just a play of mass, but what's the difference? What's the difference? But you have to look at his title, the title of his paper. This is in German. I translated into English. Does the inertia of a body depend on its energy content? That's the original paper from Einstein 120 years ago. So it's what he was having in mind was that the mass of the inertia should be understood as mass, is equivalent to mass. What he was trying to say that mass of a matter, mass of something, anything, can come from its energy. That's why he wrote down m equals E divided by C squared. So let's follow Einstein's logic and see what happens. So what really happens is that you have quark and gluon inside this proton. They must have a lot of kinetic energy. They must have a lot of kinetic energy to create such a massive particle. Nevertheless, this is something really interesting, and we are still trying to understand. Because once you understood that the particles inside the proton, they have a lot of kinetic energy, then they must move relativistically. They are moving at almost speed of light. So that also brings up some other challenges. So you have to use relativistic quantum mechanics to really study the inner structure of the proton. That's why it's hard. And we also have to rely on a lot of experiment. Right now, over the world, across the world, there are many experiments are doing things to study the proton structure. For example, in Long Island near New York, there's a new facility called ERIC or EIC, Electron Ion Collider. They are trying to collide very high energy electrons onto a very high energy proton or nuclei being to study the inner structure of proton and other stuff. And similarly, in Europe, there are two facilities, and also in China near Shenzhen, 100 kilometers away, we are also suggesting that planning to build another type of facility, experimental facility, to really study the inner structure of protons and how proton can be stable and massive at the same time. And how do we do it? Why? So let's imagine that a proton is like a watermelon. It's like a watermelon. And in the beginning, what those people did in 1969 was break the watermelon. They use electron to break up the proton and break the watermelon like this. And then you see, okay, you have quarks and gluons inside. Later on, in other experiment, in the new facility, we are going to do something more sophisticated. What do? We can slice it, and we can even send the watermelon through some diffractive scattering, or give the watermelon, or give the proton or CT scan. Without breaking the proton, we can study the inner structure of the proton. It's like the CT scan. Right? So I use 40 minutes to give you some idea. I'll give you some introduction to what we studied, what the protons physics is about, and so 50 years ago we discovered that proton really has some inner structure. On the other hand, there are still many interesting things to do. So from my perspective, physics is quite interesting, and I welcome you to ask questions and also try to study physics in universities. Yeah, thank you. This is my first part of my talk. Thank you. Let's see if we have any questions.
Okay, if you have any question, please feel free to
physics
ask
question.
about the 100-year proton physics, and I will bring you the microphone. Yes. Any questions that you would like to know more?
Yeah, so don't be shy. Don't be shy. You know Higgs. That's very, very interesting. The very few high school students know,
Yes.
know
Any
Higgs
question?
mechanism.
No.
No question. Oh,
Oh,
sure.
yes.
Yes, please. Yes, please.
Teacher, are you confident 100% that the model of electron now is correctly?
Sorry, say it again.
Model of electron. No, sorry. Model of atom.
Model of
Yeah.
atoms, atomic models or models of atom.
Yeah.
100% confident. Yes, I would say why I'm saying this. Well, because experiments, physics are really experimental science. We have conducted millions of experiment on atomic model tested. So atomic model has been tested quite thoroughly. And we are, because Schrodinger equation, what's really behind the atomic model is the Schrodinger equation. So you have the nucleus in the middle, and the electrons are acting like a wave, like a probabilistic wave outside the nucleus. So when you use the Schrodinger equation to describe the motion and the dynamics, I didn't have time to go into Schrodinger equation, but Schrodinger equation can have really, really precise prediction. And all these prediction has been checked out. So at least you may say quantum mechanics may have some, maybe there are something unknown about quantum mechanics. Maybe we have not known everything about quantum mechanics. However, our current understanding of the atomic model is quite checked out.
Thank you, teacher. I have next question.
Sure.
If someone in our in this room want to got the Nobel Prize, how
Okay.
he can get it?
How can they get it? Nobel Prize. I ask myself all the time this question. Well, I think maybe first you have to study science. If you study mathematics, there's no Nobel Prize. Second, I guess you have to have a little bit luck. You see, a lot. Also, maybe you have strong interest in science, and also a little bit luck. A lot of scientists they really wanted to get Nobel Prize, but not everyone is lucky. Yes. But that is fun. It's fun to work with science, from my point of view.
Thank you, teacher.
Okay.
Hello.
So I want to know, right now with our understanding of protons, what is the things that invented or get invented from these information or knowledge that we know?
Oh, that's a very good question. Yeah. So we have gained tremendous amount of knowledge in particle physics, in high energy nuclear physics, when we collide proton when we collide electrons. And so what have we produced out of this? I can tell you that direct application of this knowledge almost don't exist. The direct application, I don't know any direct application. On the other hand, we in studying this, we have already pushed our technology further and further. And we have already really pushed our boundary to a next level. Second, the interesting thing is the internet that everybody is using now is a byproduct of high energy collider. Half of the technology is actually discovered or invented at CERN. At CERN. CERN is somewhere here on the border of France and Switzerland. And the technology, the internet technology was originally invented to transport data in the old days, good old days. They do experiment in CERN, at CERN, and then they have to put these data onto hard disk, store them, and then send them through couriers or mail packages to the United States across the ocean. It's very inefficient, and you have to wait a long time. Then they realize that why don't I send it electronically? So half of the technology is the byproduct of the and the most amazingly, the inventor of the internet technology gave up the royalty, gave up the patent, gave up the patent. So you can use internet freely today. Everyone can use.
Thank you so much.
Yeah. On the other, also third reason why I wanted to study physics, why I wanted to study something that apparently is useless. When people invented, or when people discover quantum mechanics, they thought quantum mechanics was useless. But then 100 years later, people realized that quantum mechanics is very useful. So right now, we do not know, but it's just the curiosity that drives us to really push our boundary of our knowledge further and further. That's something that I convince myself. Thank you.
Okay, I would like to argue for two questions.
Yeah.
The first one is from the quark, like the proton that get two up quark and one down quark, and
yes.
Yeah, but I would like to know, do we have any particle that got all the same quark, like all up quark or all bottom quark?
Oh yes. Oh yes. There are. That's also the discovery of color. That's why I didn't want to go into the detail. There are particles called I think it's called omega. There is a particle called omega. Now, omega is made of 3 identical strange quarks. 3 strange quarks. Strange quarks. So you see, we have now discovered six type of quarks. One of the type is called strange. And we discovered there is a particle called omega. This particle has 3 strange quarks inside. And then according to Pauli said the fermion, quarks are fermions. They are like acting like electrons. Electron and electron, they don't like each other. They never want to stay in the same room. two electrons cannot stay in the same room according to Pauli exclusion principle. They have to be different places. Or at least you have to convince these two electrons they are not exactly the same. So that's why when we discover that the three strange quark, identical strange quark are in the same particle, they must be tagged differently. So we give them different tag. We gave them color. We give one of the strange blue color. We give another strange green color. And then the third one, red color. To make sure that these three quarks are different in order to be consistent with the Pauli principle, exclusion principle.
Okay, and the second question is I'm not clearly understand about the mass of the proton. Like from the equation of the Einstein is that m equal E over C squared, right?
Right.
That mean the mass is depend on the energy that proton get or not.
Oh, yes. Now imagine if you see the proton from outside, what do you see? Proton has this mass. But what if you can go inside the proton? You realize that proton is not really just a proton. It is many particles that are moving very, very fast inside it. So when you talk about the mass of the proton, you have to take into account all these kinetic energy of the particles. So you need to sum up all the kinetic energies and the potential energies of all these quarks and gluons. That's the explanation. So you wanted to, so these kinetic energies are actually one of the origins of the proton mass. Oh, okay.
So
please.
the last one now.
Yes.
I want to know why there's only 3 quarks in one proton. Why it can be 4 or 2? Why there's only 3?
Why not just 2?
Why 2 or 4 or more than that? Why just 3?
Oh,
The number 3, why it's so important that it just have only 3, and other ones like you talked about earlier, omega have 3 strange quarks.
right.
Why not 4 or 5? Sometimes.
Good, very, very good question. Very, very good question. To be honest with you, I do not know exactly why just precisely 3. Maybe nature gave us 3. Nature gives us 3. And why not 2 to 4? There are actually 2 quark particles. There are also 2 quark particles called meson. There are also 4 quark state, could be, but it's rare. The 4 quark states are rare. Yeah, they exist, but most important part is 3 quark state, like proton, neutron, and similar particles. They have 3 quarks inside, and these are the most common, especially proton.
Thank you so much.
Thank you.
Yeah, and also we have the question from the audience
Okay.
via live stream. So from Princess Churaporn, Nakhon Si Thammarat. So they ask why Higgs boson can create mass in nature and how mass had impact for force. Why Higgs boson
yes,
can create mass in nature
right.
and how much had impact for the force.
How much it has the
Impact, yeah, for the force. Yeah.
Well, first of all, Higgs boson. That's another story. That probably it takes a long, maybe a longer time to explain. But what happened is that Higgs boson can interact directly with electrons, with quark, with fermions, and the interaction with these fermions can generate a mass, but it cannot, because the proton is not direct it's not a fundamental particle. It's not proton has a structure. It's not elementary. So the Higgs boson, to be precise, does not interact directly with proton. It directly interacts with only the quark. So, but how does it change the interaction? I actually don't quite know how it changed the interaction, because the mass Higgs does not interact directly. Well, it interact directly with the gluon, but it does not bring a mass to the gluon. Gluon has to be massless all the time, precisely, zero mass. Gluon has to.
Yes, thank you so much. And we also have the
Sure.
several questions
Sure.
from Princess Jurapon Pisanuro. So they ask, how does quantum chromodynamics QCD exactly work? For example, how the colors assign to each subatomic or particle, and
Correct.
they would really like some example of it in the elementary particle, like a proton or neutron.
Oh, very, very good question. So why we are assigning colors to the particle? I answered part of this question, but I didn't bring up the color. So we have red, blue, and green. If you shoot a beam of red light on top of a beam of blue and green together, what's the color of the light do you get in the end? White. So you get white. So that we are using this analogy to create to describe the nature, to describe the physics here. Because from outside, you see the proton, but proton carries no color at all, has no color. There's no strong force between protons. Between protons, there's only electromagnetic force. There's no strong force. There's no color force. So proton and neutron, they are colorless. They don't carry color. But inside the proton, things carry color. So we have to explain that a proton has zero color, but inside it, everything has color. So we use analogy, like the analogy that the blue, green, and red, if you combine them together, you don't carry color. It's colorless or white. But if you go into it, if you separate them, they carry color. So physicists didn't mean this literally. We didn't mean that the proton is colorful inside, literally. We are using an analogy to describe the dynamics.
Yes, thank you so much. And there will be another question from Pisanulo campuses, from online. So the students said they are thinking about their future to planning to get PhD. So they would like to ask the chemistry or physics should be beneficial to them. So the question is, in your opinions, is the quantum theoretical physics is a good field to settle in?
Oh, yeah. I think it's I enjoy it personally. I enjoy it very much. I went to the US to study physics 21 years ago. I went to the US to study physics, to New York to study physics, and I really enjoyed studying physics. And I did quantum mechanics, and I did quantum field theory and QCD. I worked with a lot of very interesting characters, interesting physicists. I'm sure that I'm not going to get a Nobel Prize. I'm not sure I'm going to be successful, but I enjoy it. So I think quantum physics are very, very interesting, and it has a lot of application. It is really something to work on. I strongly recommend it. On the other hand, it's very hard. I have to tell you, it is very hard. And that's why I have so many gray hair. So it is very hard, but you really wanted to love it. If you really love it, it's just very enjoyable. I would strongly recommend it. But yeah.
Yes, thank you so much. And the last question about the lecture. So they would like to know about the applications of the gluons or the color forces, color force in the term of innovation or the practical application. So is it just only in electricity? They would like to know about it. About the gluon. Yeah.
I see. Um, I, as one of the students has already asked the question, what's the application of QCD, and also their direct application? I don't know any, but I would say, but something that just drives us curiosity to satisfy our curiosity is probably the only product it brings us. Yes.
Yes, thank you so much.
Thank you.
Yes. Oh, yes. Thank you for your extensive lecture about the 100 year of the proton physics. It's very interesting. I think it can inspire lots of students who would like to know more about the physics. So yes. So,
Okay.
so now we proceed to our main talk about the insightful opportunities that are available in the Chinese University of Hong Kong, Shenzhen. Yes, please.
Oops. Can you help me to do full screen? Yeah. Thank you. Okay, now let's switch gear to I will give you probably I will spend probably 10 to 15 minutes now, a much shorter time to talk about our university. And as I said earlier, you are more than welcome to join our summer camp to really experience the campus, and I'm sure you will love it. And also for the teachers, please come too. I think you will enjoy a week in Shenzhen as well. So our CUHK Shenzhen campus, we are trying to build a new global university. So it now we are one brand, two campuses, and the original campus has a history of 60 years. Was built in, I believe, in 1964. Was established in 1964, and this is the 60 year anniversary of the original Hong Kong campus. Is located in Hong Kong, Sha Tin. And 10 years ago, we have another campus in Shenzhen, across the river, across the border. So the distance between these two campuses are about 40 minutes of a bus ride. So it's actually not far at all. And there are regular buses between these two campuses. And so it was founded 2014, and we in China, we only admit about the top 1% of the student according to Gaokao. Do you know the national college entrance exam? We only admit the top 1% in domestic student admission, and we are very much interested in inviting international students to our community, because we believe in diversity. We believe in that the more different students to join us will bring a vibrant environment to our student population, and to also teaching and also living on campus. Okay. And we have already many international students. I can tell you that this year we had a record high international student. We have 240 international students joined us this year. So that's about the 15% of the total student admission population. So we in the domestic admission student population per year is about 1,500. So on top of that, we're trying to get about 240 international students. So these are the a little bit history. Also, it was established in 2014, and in 2015 we had a School of Science and Engineering. And the beginning in 2014, we only had a School of Management and Economics. And later on, we have School of Humanity. In 2018, we have LGS. And then 2020, we have Data Science and also Music later on. And in 2022, we had a School of Medicine. So these are the development of our university. And I'm from School of Science and Engineering. So I wanted to give you more about science and engineering because you are also from the science, one of the best science schools, high school in Thailand. So I wanted to emphasize science and engineering. So let me give you a number that is 380s. So 80% of our faculty member graduated from the top, from the best 50 universities in the world. So that's 50%, and 80%. Another 80% is that 80% of our graduates continue to get their master's degree, and instead of going to work, they continue, they try to get their master's degree or PhD degree. And 80% of these students, they go to a very good school, top 100 universities in the world. So that's the 380, and that's some statistics I won't repeat very much, but I wanted to emphasize that our faculty members, our faculty, they focus a lot on research, top quality, cutting edge research, and during the class, you not only learn knowledge, and you are encouraged to also work on projects, science and technology projects with them. And we have many academic workshops and forums and activities. So you are more than welcome to sit in one of them. Sometimes our students complain that we have too many seminars, too many colloquiums, too much activities. But you have to choose wisely because your time is limited. And then also AI is very hot recently. Now our school is also trying to focus on AI, and we wanted to make it international and interdisciplinary and also industry oriented. So that's the 3I we're focusing on, and we have many signature achievements in AI studies. So let me give you one of the example here. So in our ECE department, in ECE program, electrical computer engineering program, as you can see, our professor can use AI-assisted technology to create automatic driving. And on the right, you can see that the robots are combined with AI technology, and the robot can grab the bottled water by itself. Okay? Although they're still not very intelligent at the moment, but I believe that things can get better and better with today's technology. And we have a lot of research transfer with famous companies like Huawei and Tencent and the big companies within China. And our education, so we have 6 majors. Let me introduce you 3 majors for now. So math, we have math. Math can be divided into 3 streams: pure math, theory, and second is applied math, and we also have financial math if you are interested in working in financial market. And we also have physics, and research area includes what I did, what I just told you, and we also include quantum technology and material physics also the dark matter stuff, cosmology and dark matter stuff. And also we have chemistry, or area of chemistry. And the signature of these maths and physics and chemistry programs is that we give you adequate training opportunity to become a scientist. And also we have very close connection with collaboration with the CUHK campus. And then later on, we also add the material science engineering department. And in this program, it is ranked the top 0.5% in the ESI ranking in the world. And we also have the key discipline. The material is also one of the key disciplines in our programs. And also have new energy science and engineering. This is something about the battery, and also the device, also the system and the energy economics. And because nowadays, well, the carbon dioxide emission is one of the key issue that people are concerned about. So this makes the new energy and the science and engineering becomes one of the driving force in industry. So we would like to encourage students to also work on this, to learn and to work on in this area. And the most popular, one of the most popular program is electrical and computer engineering, and it has the international standard. It is aligned with international standard, and it is ranked the 23rd in Asia and 11th in China in all areas of computer science and what. Okay. Finally, it's good to be back. Technology sometimes is not so reliable. So let me go back just to give you a quick idea about our programs. And I would like to say it again. At SSE, it's at the School of Science and Engineering, we have 6 majors. First 3 are math, physics, chemistry. And later on, we have materials, and also we have new energy majors. And at the end, we also have electrical, and computer engineering, and one very popular program. And also now I'm really wanted to emphasize this is a very popular program, even among international students. So you can choose to enter, you can apply to enter this double major program. And in each program, we admit about 25 students, both every year. And so the first program is called IDA Plus. IDA is interdisciplinary data analytics. And it's called IDA. This is your major in Shatin, in Hong Kong. And if you are admitted through Shenzhen campus, you will need to choose one of the following 6 majors. The first 2 majors are from SSE. From us, there are also computer science and also FE, financial engineering from other departments, from other schools, and the marketing and also the statistics. But also there are second program, this double major, is called aerospace science and the Earth informatics, and plus this is your major in Shatin in Hong Kong, and you choose another major in Shenzhen, for example ECE, physics, new energy, or the other 2 majors from other schools. So this, and actually in next year when you apply, or maybe the year after, we will have the 3rd double major program as well. So it is focusing on materials, physics, and other chemistry and new energy and other related topics. And we have 6 undergraduate programs, and then we have also 3 teaching programs and master programs I wanted to show you. So we have not only the undergraduate programs, majors you can study. And we also have the master class, and also we have elite accelerated class. In this elite accelerated class, you can get your bachelor plus master degree in 5 years. But that pose a lot of challenge to your study, because you have to study really hard and take 40, close to 40 units of study credit every year. That's courses every year. That's a challenge. That's a challenge. But this is possible. This is possible. We also have taught master program, or also the MPhil program. And our student also 60%, about 2/3 of our students, not only study in our campus, they also choose to stay half a semester or 1 year in our partners university. We have many partner university and many programs for you to choose. And we also have this so-called bachelor master programs with our partner university. For example, you can choose to study, for example, in Berkeley, UC Berkeley, and or Columbia University. You study for 3 years, and in the 4th year you go to our partner university, but then you will have to pay for our partner university tuition. And then to fulfill your bachelor degree requirement, in the 5th year, you take courses and to fulfill the master degree requirement. So after 5 years, you can get the both bachelor degree from COHK and master degree from our partner university. This is also very popular programs. And we also have very special admission program with Shatian. So if you study for EE, electrical engineering or electrical other computer engineering, and you can if you have a GPA of 3.0, you are automatically admitted into the Shatian EE master program. So that's a special program, and our students did a lot of research and has a lot of patent, authorized the patent, and and this is the placement. As I said, close to 80 of them choose to study further for their PhD, master degree, and 80% of them are going to very good schools. And our school students are very happy. So as in the summer camp, we had a good time, and our new students are also quite happy. So you have many opportunities to show your talents. Even we have this SSC Got Talent, and this act was very popular, and we had a lot of fun with it. So yeah, that's all I wanted to talk about. If you have questions, please ask. Yeah, and welcome you. I would like to welcome you in our university next year. Thank you.
Thank you so much, Professor Dr. Chapoburn, for the extensive information about the insightful variable in the Chinese University of Hong Kong, Shenzhen. So now I would like to open the floor for everyone to submit the question or ask the question, and I will give you the microphone. So please feel free to ask. And for the audience who join us via Zoom or YouTube, you can send us the question through Google Form right now. Yes. And now we got the question already from the Google form.
Okay.
Yes, so it's from the student here, Pathum Thani, but they are not joining us here. So he asked about, are there any outstanding or famous mathematical research project in the university about mathematics research?
Mathematics?
Yes.
Oh, I didn't go into the outstanding research projects in math. I have to say, sure, but math research is not so easy, even if you have a bachelor degree. You will have to pursue PhD, although we very much encourage students to work on projects, especially math students to work on projects. On the other hand, yeah, the math projects are in general, not so easy to find because yes, I have to say you will have to become a professor, PhD, and a postdoc to really work on some math research problems. That's the norm of mathematics.
Yes, yeah. Thank you so much. So the same person,
Uh.
he said now he is the Yang Style
Uh-huh.
Yes, Taiji. So he asked us, is there any project or craft activity about Taiji in your university?
Yes,
You would like
yes.
to say?
Yes, I interestingly, I didn't have the picture. So one of the party we threw many parties. One often in our party, there is a performance, Taiji performance in those parties. So if you are interested in Taiji, of course, we have clubs. I believe that even faculty has a Taiji club. Yes.
Okay, yes, there is Taiji in this university. So please join this university.
Yes.
Thank
Yes.
you. And next one, the student asked about the specific language test that required in your university. Yeah, with specific test, English test.
Yes. There are. I believe that you need to pass the English test, either IELTS or TOEFL. IELTS need, in IELTS you need 6.5, and TOEFL I remember it's 79. The minimum score is 79 for TOEFL, and the other one is 6.5 for IELTS. There's also in order to fulfill the requirement, you also need to learn Chinese, take Chinese classes. It's also but those Chinese classes are not so hard. They're not so hard.
Think on the brochure there is the information about the required like a English proficiency test that need right for the TOEFL to it. Yes. Yes, thank you so much. And the next one from the Prisonulo campus, they asked how much that is cost to stay here in the university.
Oh,
Yes.
I see. How much? This let me convert this into US dollar. Into US dollar. So the tuition of in each year, the US dollar in US dollar is about 15,000 US dollar. 15,000 US dollar, and in Taiwan, I think it's let me think, it's half a million Taiwan. Yeah, half a million. The tuition is half a million, and but we offer scholarship. If you, for example, I came here for scholarship interview. Tomorrow I'm going to interview 16 students, and we will then recommend for various scholarship. We have scholarship like full tuition, full scholarship, honor scholarship. Then not only you are not required to pay, we will pay you. If you get honor scholarship, you will get living expenses as well. And we also have full scholarship. Full scholarship means you are exempted from paying the scholarship, tuition. And we have half scholarship, then you are only asked to pay half of the tuition. We also have quarter and 3/4 and various kinds of scholarship. The scholarship depends on two things. First thing is your interview, but not very interview, of course, is important. Second is depending on your score performance in the high school, your high school. Whether you are good in science, whether you are good in math, whether you are passing the English tests with flying color or not. Yeah. So it depends on many things.
Yes, thank you so much. Yes. So the next one, the student would like to ask about the dormitory for the foreigner student. Is there the dormitory for them?
Oh yeah,
Yes.
yes. All by law, we are required to provide dormitory for every student. So you for 4 years, for bachelor. So if you are admitted to our campus, you can get dormitory assigned dormitory room for 4 years, and it's insanely cheap. The fee is only, let me think, $200 per year. So the price tag for the dormitory is only $200, less than $200 per year. Yeah.
Any student have any question? Yes.
Okay, as you told us, the performance of the CUHK is really high. It is the top of the world, and I would like to know if I have the school score, like school grade. It's not good as well, but it's not bad. But I have the qualification and competition in the global level. Do I have any chance to get in the CUHK?
I did not quite get the last part. Do you have what, a global?
Yeah, like global award, like any competition about science. Yeah.
Oh, I see. Yes, of course. If you have some kind, if you have participated in Olympiad, physics, math, chemistry, computer, or similar Olympiad competition, and if you get some of those awards, will play an important role in the scholarship decision.
Okay,
It will add points to your profile.
I have also got the Olympic, but it's not academic Olympic. It's science project Olympic. Does it have any weight?
I'm not the. I guess so, but I'm not 100% sure because I'm not the international. I'm not working on the international admission, but I think it should. I think it should.
Thank you.
Any questions from here? Okay.
Hello.
Do you know how many Thai students in your college per year?
Good question. Exactly, because our university somehow is not very well known until this year to Thai student. And I remember we have 24 Thai students in total in our university, and 8 this year, 8 Thai students this year. So equally distributed among the schools. But we would like to have 80 if possible. That means we would like to have really more. And indeed, we have issued quite a lot of offer to Thai students after summer camp. Oh,
About before that, I heard you say that there's 15% of students that from another country, right?
yeah, international.
And how many students that from Asia and
Oh,
not from Asia?
that I do not have the statistics, but I have to tell you that maybe more than out of this 240 international students, around or about 40 are from outside Asia, and 200, the majority, are from within Asia, like Indonesia, Thailand, and the other country, and other Southeast Asia countries. Oh, by the way, about student dorm, you will be assigned to stay with Chinese student as well. So it's not like you have a separate dormitory. So our policy is we treat international student completely equal compared to Chinese domestic student. So you are going to leave, for example, you have 4 roommates, or you have 3 roommates. Each room you have 4 students in the dorm, and you may have a roommate from Greece. You may have 2 other roommates from China. So it will be mixed together. So our policy is no more, no less, completely equal, even in terms of the scholarship and also student dorm assignment, everything is equal.
What is the teaching style of your university like? Like, is there a certain style that the university promotes?
Oh, the teaching style.
Yes.
The teaching style, well, it depends on really topics. It really depends on subjects. The teaching is required to be in English, 100% is required to, because we have, so all the students are taking the same classes in domestic and international. They're taking the same classes that they are essentially joined together. They're attending the school together, attending classes together. And in physics, I am essentially treating this as a teaching. The way that I teach, but I instead of using PowerPoint, I would like to just use Blackboard. And then in physics, I use mostly Blackboard or iPad. I write on the pad and then project it onto the screen. The teaching style is pretty much like a US university. It's pretty much like a US, because the majority of our faculty members are either trained from US universities or they did research in the US. So, and I believe the studies, but more than half of our faculty members got their PhD from the US. So the way we teach is more or less the US way. And let me also put this way, because when I was a student in physics, I also have to work like a teaching assistant. So I learned how to teach when I was a graduate student in physics. So then we sort of know how build up our experience in teaching. Yeah, I understand what you concerned about. Yeah.
Thank you so much.
So about teaching, like I want to ask about like lab. So you also have like a science lab or the computer lab, right? At the
Yes.
university.
Yes, yes, of course. Yes.
Yeah. So will be most of the lab will be like the technology will be advanced too, right?
Say it again.
Like technology will be advanced enough for like doing the research too, right?
Oh, sure. Yeah. You mean the lab equipment, apparatus, experimental apparatus? Yeah, sure. In fact, a lot of them are brand new. so I guess we only have less than 10 years. We only have 10 years of history. We have to build our labs from the beginning, and a lot of lab equipments are quite new. We encourage you to, if you choose, for example, chemistry as your major, you are very much encouraged to go to the to join the lab, research, and talk to the professor, and then do the research that you're interested in. I didn't mention this because I only prepared. I wanted to have as less slides as possible. I don't want us to show too many slides.
You have any question here?
Any questions?
There will be a question from
Sure.
the Google form again from
Sure.
the student from Nakhon Si Thammarat. He said, he would like to be sorry for if this question is not polite smart because he said if he would like to be a math teacher, he would like to be a math teacher, and he looked about the game theory and statistics. Could you please advise him? Yes, he would like some advice from you.
Oh, so he wants to be a math teacher and he's interested in game theory and the statistics. And he wants to know which one is better to choose. Oh, give him some advice. Oh, I see. The advice would be do a PhD. Would be work hard and yes, do a PhD. You will have to, because if you wanted to be a math teacher, the most important aspect is to get a PhD. But math PhD is super hard. But I think it's if you are really interested in these subjects, you will find that it's very, although it's hard, but it's enjoyable. You find it's enjoyable, and you do not mind working late on these topics anymore. Yeah.
Any question here?
So
No?
so the advice is keep your passion.
Keep your passion.
Have your passion in your subjects in math.
Yes, thank you so much. Is there any question here? No.
No more?
Yes, no more? Yes, no.
Okay.
Yeah.
Thank
Okay.
you.
So
Thank you for your time.
Yes, thank you so much. So for our wrap up our today event, so I really would like to express my sincere gratitude to Professor Dr. Xiao Baowen to share the insights about the opportunity and give us the opportunity to study in your university. So yes, so everyone please give him a loud applause. Yes, thank you so much. Okay, let's be finish. Yeah. Would you like to say something before we finish our Zoom meeting?
I thank you for coming, and I hope to welcome you on our campus. And good luck with your application, and keep your passion in your study. Thank you.
Thank you. And this time, representative of our school, and she is committee teacher, also the head of our international relation, to give you some present. Yes,
Oh,
please.
thank you so much.
Okay, shall we take group photo together here? Yes, yes, please you sit here.